However, in our life, not all the data is considered as linear. So sometimes we have nonlinear data, right? If you copy my Colab and you can use my data because I upload certain data in my Colab. If you simply just type all those code in your own Colab, it will not work because you don't have my data. So we have 3 data sets, okay? So here is the first one called data number 1. The bullet point is from data set number 1. Maybe the relationship between x and y is linear in data set number 1. But it looks like linear. It draw the best linear line for this data set, okay? But what if it does not look like a linear relationship? However, you can still use the MSE value to find a linear line. So here's a linear line. However, from our perspective, it is not linear. So here, I use this package, okay? The order equals to 2, right? I don't want to use such kind of linear relation to describe this data. Order of 2 means I want to use this formula to describe the relationship between x and y. So it will try to find the best order of 2 line, which is the curve, to describe. So this is much better. Or you can use this one, this specific function, to help you to find the residual between y hat and y. Residual 就是中文翻译成残 ，residual 中文翻译成残差哈，翻译的比较怪啊，残差 ，OK， 残差的意思就是差的意思啊，就是 就 y 跟 y hat 的差了。You can find the residual value between your y and y hat. So here is the residual, okay? So for some point, the residual is, for example, 0.6, okay? Like this. So that is the residual. For a model who has less residual, 有一个 model 如果它有比较少的残差 then we consider it is a much better model, right? If you copy my Colab, you can change this parameter from 1 to 2 or to 3 to observe the residual of data set 1, 2, and 3. When you use linear model to describe data 2 or data 3, it is not that appropriate. So the residual will be larger. So you can observe the residual of your data set and to compare with some other model to make sure your residual is small enough. Okay? Otherwise, maybe you have to change your model, for example, from linear to order of 2, order of 3, and so on and so forth, and any other model. So you can see that when you change it to 2, the residual is larger. Number 3, we can see that most of the data align with linear model. However, one of the data is far away from what we expect, and that is called outlier. 后来中文叫做离群值嘛。When you use those training data to try to make a model, those outliers will affect a lot when you do the model, as you can see here. If this outlier is deleted, if you know it is an outlier, and you delete this data point, then you can draw a perfect linear regression line for this data. However, because of the outlier, okay, the model says, okay, the blue one is much better. However, as a human being, we know that it's an outlier. So make sure when you try to analyze your data, make sure you have observed the data before you make the model. 要确定你要先观察你的资料再做模型就是你输入资料的时候，你可能会不小心输错嘛，对不对？结果你打错字了嘛，结果它本来不应该在那里，就是变成 outlier 了，对不对？ Or the data collection process has some problem， 就是你收集资料的时候有些问题比如说 这个人的身高啊，原本是150公分啊，你写成150寸。There's some problem when you collect the data. So you have to clean those data before you try to analyze this data. Then you can get a better model. Okay, so you have to specify those outliers. We will cover some outlier detection algorithm in the future. Okay. So that is, if you ignore this outlier, your linear regression line will be perfect. Okay. Okay. That is even worse. Okay, that is even worse. All those data are right here. So basically, if you draw a linear line, it should be like this, right? However, here's an outlier. This outlier will dramatically affect your model generation. 就是你在产生这个 model 的时候，它会 dramatically 就是的影响你的这个 model. So that it will be a big problem. So after you delete this outlier, your model will much better. Okay. So let's take a look at a real-world example. Before we do the analysis, okay, as I mentioned, we have to observe those data, right? The process, the entire observation, sometimes we call it EDA, Exploratory Data Analysis. 中文翻译成探索式的资料分析。也就是说，你还不知道你的资料长什么样子，你总要看看它嘛，对不对？所以你要先探索它长什么样子。所以这个应该是 this process. I mean, exploratory data analysis should be applied before you analyze your data. Okay, you have to observe the data. So I provide two data sets. Okay, one is for training, the other is for testing. This is called housing data, California housing data. Okay, we have two data sets. One is train, the other is test. For training data, the table looks like this. We have total 17,000 rows of data. And how many columns we have? We have 9 columns. So that means we have 9 features. Longitude, latitude, housing, median age, total rooms, total bedrooms, population, household, media, blah, blah, blah. There are 9 columns to describe house in California. 加州区域的房子的一些基本资料。Okay. So if we take a look at the index 0, okay, so that is somewhere in California, 这个是 longitude, latitude. So the house median range means in certain small area, the median and median 就是中位数嘛，中位数。The median age of this small area, okay, the median age of housing is 15 years, 就是15年的房子啊，一个小区了啊。Total rooms 5,612 rooms, but so it should be divided by this value because in this small area there are 472 households. So in this small area, 472 houses. In total, 5,612 rooms. Okay, so that is the data. Okay, so for testing, okay, we have 3,000 additional housing data. Okay, still have 9 columns. Before you analyze your data, okay, I suggest you take a look at the information of this data. So this specific function, it says, okay, we have 9 columns. Okay, longitude, latitude, housing, blah blah blah. Okay, 9. Non-null, N-U-L-L. You can pronounce it as null or null. Okay, count. Okay, so in total we have 17,000 rows. So it says, okay, there's no missing value. So it's quite good. And as we mentioned before, you have to specify which type of data it is. It is a categorical data or is a numerical data. So it will float 64. It means it is a floating point number, which is just a number. Okay, make sure you understand that. And my first suggestion is to draw a histogram. Histogram 中文翻译成其实是直方图没有错，但是 histogram 它有一个意思是它的那个下面数字必须是连续的。好，比如说岁数嘛，0到100岁，所以它必须0到5岁、5到10岁这样一格一格这样连续的才叫直方图。因为一般我们中文讲的直方图下面不一定要是连续的哈，所以它有一点像是 distribution， 但它不是 distribution， 它就是分组资料的直方图。好 ，so that is histogram. Okay, so basically we can take a look at the histogram so that you can get familiar with the training data you use here. So as we can see, there are several interesting things. For example, right here, the median age of these houses are larger than 50, which means 50 years. Okay. So you have to think about that. Maybe I should, what you should do? Maybe you should set those bins. 啊 ，bin 是专业用语，就是分组的那个组哈。You may set those bins in the other way, so that house median age is larger than 50 years, so that you can see the distribution of this house, which is larger than 50 years. Okay, so this histogram is not that appropriate. The other thing you have to know is that it looks like it has double peak. Double peak 就统计上双峰的 distribution. Okay, so either the house is less than 20 years or between 30 and 40 years. Okay, so maybe you have to take a look at these things. Population, household, median income, median house value. Okay, or because it has longitude or latitude information, so you can draw those things in a map. So if you want to use map, you may try this. Maybe Bay Area or San Francisco, somewhere, or Los Angeles. Okay, so that is you have to observe them. Okay, the other way to see, since we would like to know the relationship between different data, different features, so the best way is to draw the correlation between two features. Since we have 9, so we can draw a 9 by 9 matrix. Each cell represents the relation between two features. So we can see that, what is this one? So we can see that some data are highly linear correlation. Okay, for example, this one. You can see this one is household, the number of households in the area. And here is the total bedrooms. So that means in a small area, if you have more household, right, and you should have more total bedrooms, which quite trivial. 就是听起来白痴嘛，就是真的没有错嘛，对不对？ It's quite trivial. But for some other, even this one, okay. But for this one, we can see that there should be. It looks like a distribution. What is the application we'd like to demonstrate? For example, we have 7,000 data right here, right? We have a long. In this case, the y value is median house value, and that is we have 7 features, right? We have 1. Another feature used as a target. So that is X, and we have to predict Y. We want to use the 7 features, okay, to estimate or to predict what is the median house value of this whole area. Question is, how do we do this kind of prediction? So the first things we may think about is, what if I use linear regression, as we mentioned before, to do such kind of data modeling and try to use it as a prediction model? Okay? But which one among those 7 features, which one is more promising? So basically, you have to think about is right here. This column, okay? This column is our Y. is the median house value. Which one of these 7 features is much more promising to predict the Y, which is the price of this house, the house value? So basically, we will choose several features, which looks like much more linear. So that when we apply linear regression, it might has a very low MS value. Okay, so that is maybe this one. Okay, this one is median house value. The other, this one is median income. So maybe median income is a proper feature to model these houses and to help us to predict the house value. Okay, in this matrix, we try to draw the correlation. Okay, I believe you understand how to calculate correlation value 啊，就是我相信你应该都知道怎么算那个correlation value 相关系数嘛，对不对？中文叫相关系数嘛，你应该知道，统计课应该有教哈，要做 correlation. So okay, it shows all the correlation value between any 2 pair of features. Median income, okay, it has a very relative higher value, 0.69. So it is promising, or maybe it is promising. We use a package, okay? I am afraid you have to learn this package by yourself, okay? I think it is not that difficult, okay? Just follow some example, just follow my example. It has a very convenient function called linear regression. So you don't have to calculate all those differentiate things. You just input all your data and ask the package to give you the optimized parameter of the linear regression answer. So here's the answer. The median house value equals to what? 7 different features, right? 7 features. And each feature has a factor. As we mentioned, y equals to ax plus b, right? So the a right here is right here, right? Right. And the b right here is right here. So you don't have to worry about how to calculate these factors, this a and b, optimize a and optimize b. We can take a close look at these things. The first thing we have to take a look is the plus. The median house value is correspond to those things. Okay? For example, if your housing median age is larger and your median house value will increase, 1 year of median age will increase 1,150 your house value. So the question is it reasonable? Does it make sense? I'm not sure the answer is yes or no. Maybe it's yes, it's yes or no. But every time you do such kind of analyze and the linear regression result shows that, you have to think about, is that make sense? Make sure you think about it before you announce those results. Okay? I don't have correct answer, but you have to think about it by yourself. Okay, why do we believe that the real world data is related and can be modeled like that? Do you believe this world is linear? 现场的哈，你相信这个世界的关系？你觉得是比较线性的？举个手吧，没有人举手。你觉得这个世界比较偏向非线性的，请举手。好，比较多。Okay, students in the classroom they said the world is much more like non-linear than linear. From my experience of analyzing data, most of the data in the real world, okay, is much more like non-linear. So basically, when we use linear regression to analyze data, make sure your target and your feature are truly linear related. Otherwise, I strongly recommend you use some other non-linear regression model to model your data. Okay, that is just an experience. Okay, so here is it. So since we have training data and we have testing data, so we use training data to make that linear model, right? So that, and after that we can use the testing data to do prediction, to calculate y hat by using those testing data and try to the difference between y hat and y in this testing data. So here is it. The blue line is the actual data, which is y, right? The y. The predict data is y hat. The testing data, of course, it is different, but the difference looks quite good, right? Looks quite good. Why this application can successfully do such kind of prediction? Because we believe the training data is large enough. They cover many different types of small area of house. And the model, it can really describe those data by using the model. So when you apply the testing data by using this model, the model already seen the training data. So it outputs similar result for that testing data. So testing data can have such kind of results similar. The actual value and the predicted value are close enough so that we can use this model to predict the house value.